The Singapore Flyer is a giant observation wheel that is said to be Asia's most visible iconic visitor attraction, providing breathtaking panoramic views of Singapore and beyond. Completed in March 2008, it is one of the world's largest man-made moving land objects. It has a height of 178 meters, a diameter of 150 meters, and sits on a 28-meter high, 3-story building. During the testing phase, the Singapore Flyer goes through a series of continuous revolutions without stopping. Assume that it revolves at constant angular speed omega, and each complete revolution takes 37 minutes. Calculate the angular speed of the Singapore Flyer. The angular speed is given by 2 pi over the period, and the period is 37 minutes times 60 seconds. So that gives 2.83 times 10 to the power of minus 3 radian per second. Hence or otherwise, determine the speed of a passenger capsule which is located at the circumference. Now the tangential speed, V is equal to R omega, and these substituting values will give us 0.212 meter per second. Given that there are 32 equally spaced capsules on the Flyer, find the time taken for capsule to go from position X to position Y. So the time is the change in the angle divided by angular speed. So substituting values, we get 139 seconds. The Singapore Flyer now revolves at a much faster rate, such that the centripetal force on the passenger becomes about half his weight. Draw and label the forces acting on the passenger standing inside a capsule at the 3 positions in the figure shown below. So the weight is in red. So the normal contact force is upward at the top, and this is half, so that the resultant force will be pointing downwards, and there will be half the weight of the passenger. Now at the bottom, the normal contact force will be pointing towards the center of the Flyer, and it is 1.5 times longer than the weight. So the resultant force will be half the weight pointing towards the center. At the side, the normal contact force will cancel the weight, and there's a frictional force, there's a half W that's pointing towards the center. So these are the forces acting on the passenger at the 3 different locations. Since the Singapore Flyer revolves at a constant angular speed, no energy is required to keep it revolving once it is moving. Discuss briefly the validity of the statement. The statement will be correct if dissipative forces such as friction and air drag are not present. However, friction at the axles, hubs and turning mechanism, as well as air drag acting on the passenger capsules and Flyer structure, cannot be avoided. Hence, energy must be supplied by motors to maintain its rotation at constant angular speed.